Clear? So I will explain like how vehicles are moving on a circular track. For example,
Okay, sir.
they are moving. This is circular track. This is circular track, and on this circular track, one vehicle is there. Let us suppose this is a vehicle.
Sir, the road is banked or flat?
Flat, flat, flat. Not banked.
Okay.
Flat. Okay.
Okay, sir.
So meaning is that this car is like this. This is the road. On this car is put like this. Car is like this. Okay. So meaning is that this car is moving on a circular path like this. This is the path of the car. Okay. This car is having
Okay.
certain velocity. Car path na there is some velocity. It is moving with certain velocity. And this is the what? Center.
Centripetal acceleration.
If you are the observer, you are standing on the ground. Clear?
Yes, sir.
If you look at this car, then what will happen? If you are here, or if you want to understand like yesterday topic, then it is more easy to understand. If you take the observer that is standing on this car, this is the observer here,
Okay, sir.
then it will be more clear. If this observer is on the car, then he is observing this car. This car is having the mass small m. Clear?
Yes,
Then
yes.
when this car is moving on a circular turn, clear what? Turn. Turning of car. We are mainly discussed regarding turning of car. All the things we are learning because of when car is taking a turn. See, car is moving on a straight road. Then it is taking turn. Our point of study is turning. When car is going to
Okay,
take
sir.
a turn, here everything we are going to learn here only. Whatever things I am going to teach you for turning of car on a circular track, not tracks, turning of car on a curve. It may be complete circular, it may be little bit curve. Okay. So my main objective is to help you how the car is moving on a circular track. That is my main point of discussion. So if you are the observer, you are standing on this car, then your frame is moving frame. That is non-inertial frame. What is non-inertial frame?
Frame.
Yeah? Non-inertial frame.
Okay.
Because you are in the car or you are on the car. Then if I ask you, you will feel one force that is away from the center. Away from the center. That is pseudo force. We say that
Cent
pseudo force is centrifugal force.
force. Okay, sir.
That is away from the center. And how to find the magnitude of the pseudo force? Mass of the object
Car.
multiply acceleration of this as seen from the ground. If you look at from the ground, there is no centrifugal force. Clear? If you look at from the ground, this car is moving on a circular path. And it is possible to move on a circular path because of centripetal acceleration AC. That is V square by R. Then it will be AC. Okay. Now this pseudo force. Clear? Pseudo force definition is mass of the object on which law is going to apply. Multiply acceleration of non-inertial frame as seen from the ground. If you look at from the ground, there is no pseudo force because you are in the inertial frame. Clear? This
Okay, sir.
pseudo force exists only when you are in the non-inertial frame. Clear? Now, if you are standing on the car, you are the observer, then you will feel when car is taking a turn, you are going away from the center like this. Your car is going to skid outside. Clear?
Yes,
Your car
yes.
is going to skid because of this pseudo force, or we say here pseudo force is centrifugal force. When you have observed or not, when you are moving your car on a circular track, then you are feeling you are moving away from the center like this. Centrifugal force.
Okay,
I have
sir.
observed you if you are moving your car on a circular track or any curve, then you will feel one force is away from the center. Clear? Is it clear?
Yes,
AC,
sir.
mass into AC. So AC will be V square by R. Now you please tell me, if this object, if you are on the car, clear? If you are in the car or you are on the car, for you, car is at, with respect to car, your velocity is 0. Clear?
Yes,
With respect to you, this net force on you will be 0 because there is no acceleration. Clear? If you are on the car,
okay.
then with respect to car, you are at rest. Clear? If I ask
Yes,
not
sir.
you, if I ask like you are in the car and you are the
Okay.
observer, then with respect to you, you are feeling that car is not skidding outside. Clear? If I ask you,
Okay.
you are in the car. You are in the car. Okay. And car is taking a circular track. Then this car, you are feeling this car is not skidding, is not accelerating. Why? Why? You will feel
Sir,
car is at,
because
because your acceleration
rest.
and the car acceleration is same. Clear?
Okay, sir.
Your acceleration and
Yes, sir.
car acceleration is same. So with respect to you, car is at rest. If you are not looking outside, you are in the car. If you look at all the objects in the car, then entire thing is at rest. If you will not see anything from the window outside, then you are at rest with respect to car. And car is at rest with respect to you. Clear?
Okay.
Because you are in the
Yes, sir.
non-inertial frame. So net force on you will be 0. Now net force will be, one is pseudo force away from the center. It should be 0. Then you please tell me pseudo force is outside. I am writing pseudo force. That is minus F. Then I need to make it 0. Then who will make this 0? Friction. Friction will be like this. Towards center. Clear? Is it clear?
Okay, sir.
Then
Yes, sir.
friction will provide the, friction will balance, because we need balance. We need balance because you are in the car. When you are taking a circular turn, your car is not skidding outside. Then who is protecting you? Who is balancing this centrifugal force? Friction. Clear?
Friction.
So friction will balance
Okay.
your car. Friction will provide this pseudo force. Not pseudo force, that
Sir,
is
the
equal
car
to
is
pseudo force. Pseudo force
sir, the
is
car is moving
centrifugal
in this
force.
direction. Sir,
mv square by r. Huh. Car is moving
the
in this
car is
direction. It will
uh,
skid like
then
this.
friction will be in opposite only, no, sir.
Friction, you please tell me. This car is moving on a circular track. Clear? Then
Okay, sir.
these
Yes.
are the wheels of the car. Clear? This car has a tendency to move away from the center. Clear?
Yes, sir.
This
Yes, sir.
friction. So our objective is this car, the wheels. The wheels should move like this, away from the center. It is going like this. Clear? Then friction always opposes the tendency of motion. So it will be like this. Clear?
Then friction will not act in the opposite of the motion, sir. Like friction will not act in this direction,
Friction
sir.
always opposes you. My question is what? My question is, when a car is taking a circular track, circular turn, that time I'm saying, on a circular turn,
Okay.
car should not skid outside. Clear? If it is skidding outside, then friction will stop it. Clear? Clear? Here friction
Yes,
is
sir.
there. Listen, if you are making your if you are slowing the car, if you are slowing your car will stop on a circular track because of rolling friction. Friction will be there, but one friction will be where this friction which I have drawn here, this friction opposes the tendency of motion in this direction like this. There will be two friction, you can say.
Okay.
Clear? Clear to you?
Yes, sir.
Your car,
Yes, sir.
for example, this is the road, width of the road. This is the width of the road. Clear? Here, this is your car. This is your car. Clear? When you are taking a circular turn, your car wanted to skid outside. Wanted to skid outside. will try to slip because of centrifugal force that is away from the center. It will try to skid it outside. Then who will balance this? Friction. This friction, because friction always opposes the tendency. This wheel has tendency to move outside like this. Then this friction will act in opposite direction and will balance this. Clear? It will balance the centrifugal force. So friction will be what? V is equal to R omega square. So it will be mr omega square. Friction every time will balance the centrifugal force. So that
Centrifugal. Okay.
smooth turn, you can take a smooth turn. It should not skid. You please tell me, you are moving on a valley. Valley, this side danger, this side danger. Then you want like your car to slip? No. This width is very less, huh? If this width is very less, if you skid, then you will met accident. Clear? You will die. If the width is very less, automatically width is very less. If there is no proper friction, then your car will skid. Your car will skid and you met with accident. So to avoid this, there must be one friction. There must be one friction. Clear? There must be friction,
Okay.
or else you should slow your car. You should slow down your car. So actually, this is the car and this is the wheel. This wheel has a tendency to move like this direction. Then this wheel, because of the centrifugal force, this car always wanted to skid outside. Clear? Skid outside, away from the center. But this friction, this wheel is in touch with the road. This wheel is in touch with road. It will apply a friction force like this. It will oppose the tendency of motion. Tendency of motion will be in this direction.
Okay,
Listen,
sir.
here in this direction car will not be moved. Which friction will be here? Static. Static friction. Okay. What I'm saying, car should not skid. Skid means car will be at rest in this direction. Clear? Rolling friction different. Your car is moving like this. Okay. That is rolling friction different. I'm saying regarding this. I'm talking about this. My main objective is to tell you what should be this V. What should be this V so that your car should not skid in this direction. Car should not skid in this direction. Skid means it should
Okay.
not skid. Not skid means it should be at rest. It should not move away from the center. Clear? Now,
Yes, sir.
meaning is what? You please tell me then, if your car, if you do not want your car, for example, you want your car should not skid, then on a circular track, center, your car is here, small r, car is here. Clear? Your car has wheels. These wheels are providing friction force towards the center and it will balance the centrifugal force so that car will
Centrifugal.
not skid in this direction. Will not skid because this is the width of the road. Clear? Will not skid in this direction. Clear? So friction. Is it clear to you?
Yes, sir.
So this friction must be greater than equal to centrifugal force, that is mv square by r. Clear? Now m will be
Okay.
mr omega square. Now you please tell me this friction. What is the meaning of this? I will tell. I will draw F versus mv square by r. Now listen. This friction is self-adjusting nature. For example, if you are increasing your speed, m is constant, mass of the car is constant, v and r. This v and r will vary. If you are moving your bicycle, for example, car with 100 km per hour on a circular turn, let us suppose centripetal force generated 5 Newton. Clear? Then friction become 5
Okay.
Newton. If you are increasing this 6 Newton, you are increasing the speed of your vehicle. Centripetal force becomes 6 Newton. Then your friction will make it 6 Newton. Self-adjusting nature. If you are increasing 7 Newton, it becomes 7 Newton. Then 8 Newton. Then it becomes 8 Newton. But 8 Newton its maximum value. Up to this value, it can adjust. That is known as limiting value. Clear? Even
Sir,
if you are
how can we find that?
Huh?
Sir, how can we find the maximum value, sir?
I will tell, don't worry. Clear? I'm just giving you
Oh,
example. Clear? Even if you are increasing here, velocity is 100, let us suppose, velocity of car 120, 140, 180. So up to 180 kilometer, your car will not skid. Car will not skid because friction is supporting you. Friction will balance, will not skid. Clear? But even if you are increasing
oh,
your, for example, you are again increasing the speed of your car. For example, you have increased more than 180. Then it becomes 9 Newton. Then friction is still maximum because it can't increase its value. It has maximum is 8 Newton. Clear? Then who will win?
yes.
If you please tell me,
The
if
centripetal
yeah,
force.
yeah, you please tell me, this is the width of the road. This is the width of the road, and you are taking a turn like this, and this is center. Clear? This is R. If the centripetal force is high and friction is maximum value is, let us suppose 8, you are applying 13 for example, then who will win? Tell me.
Centrifugal force.
Centrifugal force will
Centrifugal
win.
force.
Then this car, earlier it has radius how much? It has radius R1. Let us suppose R1. Clear? Earlier it has
Yes.
radius R1. Now it is moving in this radius. Its radius will increase now.
So radius means inner radius or outer radius, sir?
Inner radius, not outer radius. Simply understand this is the road, circular track. Car is moving like this. Earlier car is moving like this. Here, center,
Okay.
R1. Now car little bit skid.
Okay.
Skid means it will come here. It will come here. Again balance. Why balance? I will tell. When car is here, its radius will increase now. R2. It will skid. Clear?
Okay.
Now when it increase, when it skid, then again it come back to 8 Newton. Why? Because centripetal force is mv square by r. Even if you increase this v, because of this v, r is also increased. If r increased, again centripetal force decrease. Again 8 Newton, 8 Newton. It will balance. Okay.
Okay, sir.
Then if you increase the velocity more than that, you are moving very high velocity. For example, here, how much more than that? 9 Newton or 30 Newton. Let us suppose here velocity is 210 kilometer per hour. Clear? If you are moving more than that, let us suppose 250. In 250, you will be here on. Then here, road width is this. You are crossing the barrier. You will die. Met with accident. So,
Okay.
I am saying like, even if you are increasing the speed, if you are increasing the speed, then you will take a longer turn, long turn. Clear? You will take a long turn. Have you seen like a racing track? Racing track when they are taking a circular turn, then their radius is very high. If you see like F1 race, then they are taking very long turn. Why long turn? Because when they are moving on a circular turn, they are not decreasing their velocity. They want to move at the same velocity. If they want to move with the same velocity, they need to increase the radius also. Then only they will our friction will balance. Otherwise, have you seen like sometime like when they are moving on a circular track and they are increasing the velocity that much, their car is also skid outside. Have you
I
seen like
approve.
those
I
those
approve.
cases? So width of road is like it is fixed. If you move on a road, this width is fixed. Clear? So we can't increase the width or decrease the width. It is fixed. What we can do, we can take the help of friction. That's friction because that have you seen like they are saying like on this road, the maximum speed is this 100 kilometer per hour, 60 kilometer per hour. So that is as per the like this observation. Now you please tell me the F must be more than mv square by r. I'm telling. Clear? Now
Okay.
if I ask you like what is the maximum how much? If F is equal to FL, then this velocity which you calculated is the maximum velocity or safest velocity. How much? V should be less than equal to FL will be mu s into N. That is R by M. Clear? Now what is N? If this car is on the
Sir,
road. Clear? This car is having the
okay,
mass M. Mg is down. If you look at this view, N is like this. Flat road. Okay, flat. It is not banked. Centrifugal force is this direction. Friction will be like this. Clear? Now here,
okay,
normal will balance. Normal will balance the Mg. Okay. Then V will be under root. N will be Mg R by L. So maximum velocity, what should be? Under root mu s Rg. Very important. So safest velocity for a turn. If you want to take a turn, this is the circular turn or track, let us suppose. If you are taking a safest turn, if you want to take a turn, clear? Then
okay,
safest
sir.
velocity here should be, when you maximum velocity, how much? This V should be less than equal to under root mu s Rg. So maximum velocity will be how much? Under root mu s Rg. Now this mu s depends on road, and the tire,
Okay,
surface and contact. R is the radius, G. So you will put the value of R, G, mu s. Then maximum velocity will be this. If you are crossing this maximum velocity, then friction can't balance. Clear? Friction can balance up to this
okay,
velocity. Even if you increase, then your radius will increase. Then you need to take a longer turn. Then only safest this V max you will achieve. Clear? Even if you want to move at a
yes,
more than that velocity, if you want to move, then you need to take a longer turn. You can't take a sharp turn. Have you seen roads are like this? Some roads are like this. For example, this straight road, clear, car is moving like this, then they are taking a turn like this. So at this turn, this is circular, na? Circle. This
yes,
your
sir.
car is like this. This car is moving like this. Here it is moving, taking a turn. Here this car is taking a turn. This turn is curve. This curve has some center. Clear? This curve has some center. This curve has some radius. So here, what should be the velocity of this car? It should be maximum can be under root mu s r. Clear? So when a car
Okay,
is
sir.
moving like this and it is taking a circular turn like this, then on the circular turn, here velocity must be maximum velocity must be under root mu s r g. Because mainly there is a problem on turn. When you're taking a circular turn, there is some problem. There is more chances of accident. Clear? That is why this topic is here. Next is like if I ask you, if the roads are like this, if you want to move your vehicle here, how much sharp turn? Did you see sharp? How much sharp is it?
Sir, almost 90.
Almost. So it is not sharp turn. This is sharp. So if you want to move, if you want to take a turn on sharp turn is sharp turn, very very sharp. Its radius is very very small. Clear?
Okay,
If you want to move here, then you need to take very 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 slowly. You should move like this your vehicle because here radius is very less. Then V should be very very less. Clear? If sharp turn, very very sharp, then you should move your vehicle very very slow. Otherwise, you will definitely meet with accident.
okay, sir.
Clear?
Yes, sir.
Next is now what is the need of banking? I will tell. 1 minute. I will add some more slides. What is the need of banking? Like banking means, for example, if you are running, sometimes like it happen like during rainy season. During rainy season, what happened like your car slip. Have you seen this? Why
Yes,
your
sir.
car slip? Because the friction decrease. V is equal to what is the safest velocity at which you should move when friction is there? Under root, maximum under root, mu s rg. This is safest velocity. If you are moving your vehicle with this maximum velocity, then you will not meet with accident. You can easily take a safe turn. Clear? This is safest velocity.
Okay.
Safe for safe turn. For safe turn. Now here, who will supporting you? Friction. Up to this. Let us suppose you are crossing this barrier. You want to cross. You are asking like, you are asking a question to me, sir. I want to take a turn that has velocity more than this. I want to take a turn that has velocity more than this, and my car should not skid. My car should not
So
skid.
increase the radius of turn.
No, no, no. Even I'm saying not skid. Not skid. Matlab means I don't. I'm not interested to increase my radius also. Clear?
Okay.
Increase radius means it will skid. Then it will not skid. Clear? First it is skid. Then it will not skid. My question is, even I am increasing the velocity. Even I am increasing the velocity of the car. It should not skid. Clear? So my question is, how we will overcome? How we will overcome this problem? The problem, how we will overcome? With the help of banking. What we will do in banking? For example, this is the track. This is circular track. Okay, circular track.
Okay.
Little bit like this. This is track. Clear? This is the track. This portion, little bit. This portion, this side way. This side portion, na. This
Yes, sir.
side. This is all side. Side portion of this road, little bit lifted, like this. Little bit we will lift.
Okay.
That is known as banking. Clear? So if I ask like, what is banking? Like this. Like this. This is straight like we are increasing. This portion I have lifted. Like this. This is angle of bank. Earlier road is like this, okay? That is side portion of the road. This is road, our road. Circular track is, earlier ke theta is 0, okay? This portion we have
Okay.
lifted little bit. Side portion. Clear? This is known as banking. Why we are doing banking, I will tell. This is angle of banking. Angle of banking. If I ask you, for example, when there is no banking, when there is no banking, car is like this. Car is like this. Okay?
Okay, sir.
One. Start or not? Yes, it is charge. When there is no banking, car is like this. The weight of the car will be like this, mg, and this is the normal. And centrifugal force will be like this, and friction will be towards center. Okay.
Okay, sir.
If you little bit raise, clear, then still, if car is now this, car is placed like this. This is the view of the car. Clear? By doing this, what actually we are doing? What is the benefit of this? Let us suppose there is no friction, even friction fail. Clear? Then
Okay.
still car will not skid. Why? Because of this, there is normal. Let us, this is theta. This is the normal. This is the normal. Clear? This normal is making some angle with, if you look at carefully, this is 90. This is theta. Clear? Clear?
Okay, sir.
Now, still one component of this will be n cos theta. N cos theta. Weight will be like this. This is the weight of the car. N cos theta. One will be, it will be like this. N cos theta and sin theta. Not here actually. This one. Wait. I think I should use eraser. No. Okay. Clear? This is not
Okay,
in this
sir.
direction. One n cos theta, one is n sin theta. One. This is n sin theta. Okay. When this car is like this, initially car is like this. This is road. On this road, car is placed like this. Then centrifugal force will be like this, and friction will be like this. Weight mg, normal up. Even if you increase the banking like this, clear? Centrifugal force is like away from the center. Their road center, away from
Sir,
the
I
center.
can't see what you are writing, sir.
I didn't write actually.
Oh, okay, sir. Okay, sir.
I'm just explaining like, clear?
Sir, here the centripetal force will be in this direction, sir.
Ah, I will show you. Okay. Wait. Centripetal force will be along this. This is the radius. Clear? Center. And centrifugal force will be like this. Centrifugal force. Clear?
Okay, sir.
Centripetal force here, who will provide? Who will balance? And sin theta.
Friction. Oh,
Friction,
okay,
let
sir.
us suppose friction is not there. We are taking a case where friction is not there. Then n sin theta will be equal to centrifugal force. That is how much? Mr mv square by r. Clear? And cos theta will balance what?
The
And
centrifugal force.
and cos theta is up now. It will balance the weight.
Oh, okay, sir.
Earlier case car is like this now. There is no normal. Centrifugal force is like this. This is the center. You raised it. You raised her like this. Now you raised like this. Car is here. This is this R na. This is centrifugal force. Will be away from the center. Now it is moving like this. Clear? I will show you when
Okay.
I will show you because it should be clear. Actually, this topic is little bit imagination is required. Banking. Show you. This is okay. This is okay. Can you check this?
Sir,
Is it visible?
what? But try the Microsoft, sir. Microsoft presentation.
Not visible, na?
PowerPoint. Not visible,
Not
sir.
PowerPoint. Just
PowerPoint.
wait 1 minute. Okay,
Oh,
1 minute. 1 minute. This is banking. Clear? Here
Okay,
road is
sir.
banked sidely. I will tell what is this. If you look at carefully, normal will be like this. Clear?
Yes, sir.
This is theta. This is theta. One component will be n cos theta, and one component will be n sin theta. Clear?
Yes, sir.
This n cos theta will balance mg, and this n sin theta will be equal to Fc, centrifugal force. Equation 1. Equation. Clear?
Okay.
Okay. Because it is moving in a
Okay.
circular track, na circle. Circle has some radius. One centrifugal force, one component of normal will be n sin theta. That is along the center. So here, let us suppose there is no friction. There is no friction. Then who will balance n sin theta? Component of normal will balance the centrifugal force. So it will not escape. Here, even if I divide, let us
Okay.
suppose equation 1 by equation 2. Tan theta will be mv square by r by mg. Tan theta will be b square by r. So we will be under root rg tan theta. This is the velocity when component of normal will balance the centrifugal force. Clear?
Yes, sir.
At this condition, car will not escape. Car will not escape. Clear? There is no friction. I'm saying
Yes.
even friction zero. Even friction becomes zero, your car will not escape. That is a benefit of bike. But it is not possible like there is road, there is no friction. Friction will be there. Like this. Banking. Clear?
Okay, sir.
This is centrifuge. Could you check this?
Sir?
Can you check this?
Yes, sir.
This is your car. Normal and cos theta and sin theta. Clear? And this friction.
Yes.
Let us suppose there is friction. This is the friction. Clear?
Sir, actually, these questions are asked for midterm or exam, sir. But I didn't tell you.
I will explain. Okay, don't worry. I will explain each and everything. This question
Okay,
asked
sir.
na. I will explain when, what is the direction of friction also. Now see, meaning is what? This is circular track. We have raised. Little bit we have raised. This portion. Clear?
Yes, sir.
If you raised, we have give too much banking. Which we can't give, okay? Like I am telling like this. This is your vehicle. Clear? Vehicle is
Yes,
there,
sir.
weight is like this. This is normal. This is theta and cos theta. Perpendicular to this and sin theta. And this is the centrifugal force. Clear? This is theta. Okay, Dinesh?
Okay, sir.
This is acting there. Center is here. Okay, center is here. So n sine theta will balance the. I'm writing what? You please tell me n sine theta, n cos theta will balance the weight mg. The value of n is constant here. Mg by cos theta. Clear? This theta, when
Okay,
you
sir.
are doing banking, this theta has become constant. M is constant, G is constant. So n is constant. N is constant. It means if I draw the data, for example, n sine theta versus centrifugal forces mv square by r. N sine theta has maximum value. How much? How much maximum value? Let us suppose it is 5 Newton. Then it can, for example, mv square by r. If it is 5 Newton, then no problem. Clear? No problem. 5, no problem.
Okay.
But if you are increasing, for example, 7 Newton, this, it is 5 Newton. Then your car will skid where? It is going away from the, it will cross the barrier. Clear? The centrifugal force is more than n sine theta, then this car is moving like this, is going like this. Clear? Okay?
Okay, sir.
It will move now, skid outside. It will go like this, like this. Okay? If you look
Okay,
at
sir.
carefully, one component, if it not component, even I'm telling, the centrifugal force here. If you look at this diagram, here, this question like this car will skid like this, like this. Here, this barrier, this barrier. This car will skid like this. It will go like this. It will increase the radius. It will move like this, and it will increase the radius. Clear? This radius will
Okay,
increase.
sir.
Clear? So you please tell me. My question is, if n sine theta, is less than mv square by r, then the vehicle, this is a vehicle wheels. These wheels have a tendency to move in which direction? This direction, no?
Centrifugal force alongside.
Yeah. Here they will move like this, skid
Yes,
outside.
yes.
Then friction will act like this,
Opposite to that.
tangentially to the, like this. Okay.
Okay, sir.
If this is theta, this is 90. This is 90 minus theta. This is called theta. Then one component of friction will help this normal. Clear? Now who is helping this normal? Friction. Clear? F cos theta, this is F sine theta.
Theta.
So N sine theta now, earlier N sine theta, now here, who is helping? F cos theta. Now even if he is increasing the velocity, this is 5 fixed, okay, 5 Newton. F cos theta, let us suppose it becomes 7 Newton. Then F cos theta is static, self-adjusting nature, it will become 2 Newton. You are increasing this, you are increasing the velocity of car, it is 5, it becomes 3 Newton. Clear? You are increasing the velocity of your car, centrifugal force become 11 Newton. Then friction will adjust, again balancing. No skidding. It become 6 Newton. Clear? Now,
Okay, sir. Yes.
up
Yes.
to this, let us suppose 6 Newton is the its maximum. Maximum what? 6 Newton is the limiting value of this friction. What is this? Limiting value. Clear? Even now you are increasing. Let us suppose 15 Newton. Then It can't cross this limiting value. Limiting friction has its maximum value 6 Newton. Up to this it can go. Then 11 Newton, that car will skid where? Like this. Clear? Car will skid where? It is out of the, away from the center. Like this.
Yes, sir.
Clear? Away from the center. Now my question is, at this position, car has maximum velocity, no? Up to this position, at here, car has V, maximum velocity. When friction is there. Clear? If a person is running with this velocity, then the car will not skid because friction is helping. Car will not skid. Maximum velocity. Car will not skid. Clear? Clear, Dinesh?
Yes,
If
sir.
car will not skid, here, what is the equation then? If I ask you, this car will not skid. You are running
Sir,
your
even
vehicle.
friction, sir,
Yes. Hmm.
even if friction, even if the velocity exists for limiting friction, it will not spin, no, sir.
Even no, it will not increase because limiting friction maximum value is 6 Newton. And sine theta maximum value is 5 Newton. It is constant. Who can adjust only friction, static friction? 2, 3, up to 6. Up to 6 it can go. But even if you are increasing more than 11 Newton, you are increasing your velocity more than 11 Newton, then your car will skid. Definitely it will skid. I am asking what is the velocity, what is the maximum velocity at which your car will not skid?
Sir, n sin theta is a fixed constant, sir.
And sine theta is constant.
Okay, sir.
Then if you look at carefully, this n, if I write equation n sine theta plus what? F cos theta will balance. That is our case. It will be equal to what? Centrifugal force, mv square by r. And if you look at vertical, n cos theta will balance mg plus f sine theta. Mg plus f sine theta. Clear? My
Okay,
question
sir.
is, we can go up to what? Up to what maximum velocity you can run your vehicle without skidding? No skidding.
Square root of RG tan theta.
No, that is different thing. Under root RG tan theta, you are going more than that. Under root RG tan theta, here only normal. Normal is there. You are going more than that. Even you are going more than that, okay? This safest velocity.
Oh, okay.
Even if you are going more than under root RG tan theta, then your car will not skid. I'm telling. Clear? What I'm saying? Listen. Under root RG tan theta, I do not consider nor friction. Clear? I am saying under root RG tan theta, you are moving with that velocity under root RG tan theta, your car will not skid. My question is, if you are moving more than that also, then still your car should not skid. Then at that condition, what is that condition? What is the maximum velocity? That is my question. So in previous case, normal component of normal is balancing. In this case, friction and normal both are balancing. Previous case, I do not consider friction. Here I am considering friction also. Because my question is, even you are going more than under root RG tan theta, your car should not skid. So let us suppose under root RG tan theta is 10 meter per second. Clear? You are going with 10 meter per second, your car will not skid. But if you are going more than 10, means 12 meter per second, then your car will skid. But you do not want your car to skid. Then in that condition, friction will support you. Friction will support you. That is this case. Friction will support you. My question is, up to what point, up to what maximum velocity you can run your vehicle on a banked road so that your vehicle should not skid? My question is that.
Okay.
So I did nothing. I simply just discuss this n sin theta plus f cos theta. This is where what is the direction of n sin theta f cos theta? It is towards center. Clear? Centrifugal force away from the center. So you are increasing the velocity. By increasing the velocity, this mv square by r is continuously increasing. 7, 8, 11, 15. So friction n sin theta is constant 5 Newton. F cos theta. F cos theta. F is what? It is friction. Friction can static friction. I want my car should not skid. So even if you are increasing 8 Newton, then 5 Newton is you are having 5 Newton from normal. Clear? Then who will give you 3 Newton? Who will give you 3 Newton?
Friction.
Friction. If you are increasing your velocity, your centrifugal force is 11 Newton. Then you have 5 Newton in your pocket. Then who will help you? Friction. He will give you 6 Newton. So that your car should not skid. But friction has certain limiting value. That is 6 Newton. More than that, it can't cross. Clear? That is why 5 plus 6, 11. 11 is towards center. 11 is away from the center. This balancing condition, car will not skid. And at this condition, centrifugal force is 11 Newton. Your velocity is very high. Velocity of this car is very high. At this velocity, if you look at carefully, at this velocity, which I have shown here, do you see?
Yes, sir.
Yeah. So at this velocity, your car will not skid. Okay. This V max at this velocity, my question is finding this maximum velocity. So I just simply do the balancing. Now you please tell me, n sine theta is constant for maximum velocity. This F can be what? Mu as value. Maximum
Yes,
value is limiting friction, and that is mu as n. Clear?
yes, sir.
Is equal to m. Now this V become V max. Okay. Now what is I'm telling? Put the value of n. Just take the common n. If you take a common from n from here, it will be sine theta plus mu s cos theta
Cos theta.
equal mv square by mv square. Clear? Now put the value of n. From this equation, what is the n? mg plus f. F is what? I think first we should find this f also. Now, what is f? First we will find, I need n. Okay, this is equation number 3.
Okay,
Equation
sir.
2. Okay. From equation 2,
Okay.
n cos theta equal mg. This f. Fl, how much? It will be mu s n sin theta. Okay, Dinesh? I need to
Yes,
find
sir.
this n. N will be mg by cos theta minus mu s sin theta. Okay, Dinesh?
Okay, sir.
This is the value of n. Now put this value n, you will get the maximum velocity. It will be mg sin theta plus mu s cos theta equal mv square by cancel. Okay, so v square will
Okay.
be under root stack. It is maximum velocity, same expression in written in our NCRT.
So the previous equation is it without friction and this equation is with friction, sir.
Yeah, this is with friction.
Okay, sir.
Under root rg tan theta is without friction. This is the maximum velocity you can go. Cos theta minus mu s sin theta. Clear, Dinesh?
Yes, sir.
If you check also from the book, you will get it is written there maximum. This is the maximum velocity. Your car will not skid. You can check, okay?
Okay.
Any doubt?
No, sir.
Check once again, okay? It is very important. Maximum is under root rg sin theta plus mu cos theta minus mu is exactly correct. Okay, same thing it is written in book. Clear? Now my question is, Resh, one
Okay.
question if I ask you, this is maximum. My question is, if you decrease, let us suppose, I have told just now, I told n sine theta plus, I think, us FL. That is not FL, F sine. I think F sine or what? F n sine theta plus F cos
Yeah,
theta. F
right.
cos theta. Data and data. Okay. F cos theta versus. Now we will understand minimum velocity. Okay. Minimum velocity. Here maximum is
Okay.
what? Total. It is 5. It is 6. For example, you are running at 11 Newton. 11 balance. Okay, Dinesh.
Okay, sir.
Now my question is, Dinesh, uh, at what minimum velocity? What is the minimum velocity? Now, for example, you are decreasing this. You are decreasing your velocity. You are decreasing
Okay,
your
sir.
velocity. When you are decreasing your velocity, mv square by r. When you are decreasing your velocity, then what will happen? Let us suppose,
Uh,
let us suppose you are making this 3 Newton, not 3, I think 5 Newton, clear? 5 Newton.
okay, sir.
Then n sine theta is 5 Newton. Friction will be what?
Zero. But
0,
it can't be like zero, sir.
clear? So n sine theta will
Okay.
balance. There is no role of friction here. Even if you are decreasing your velocity again, your centripetal force will decrease more less than 5. Okay. At 5, at 5, what will happen? Centrifugal force will be balanced by n sine theta. There is no problem. Okay. Now
Okay, sir.
my question is,
Sir,
see, this is the case. You please tell me, Dinesh, if I ask you, okay, in which direction friction I should add so that there should not be skidding. If you are decreasing less than that, for example, you are decreasing the centrifugal force less than 5, it's 4 Newton, then it is 5. Then net force will be n sin theta increase. Then this car will move like
move
this.
towards the center.
Center, it means its radius will decrease. When radius will decrease, then again it will increase. Again it become 5. Here,
Okay, sir.
see, you are decreasing this V. Okay, all right. When you decrease this V, this become 4 Newton. Clear? Then radius will decrease. Radius decrease, again it will increase. Again it become 5. My my question is, even I am decreasing this, even I am decreasing my velocity, my car should not skid. My car should not skid. Then friction, the tendency of this motion will be like this. It wanted to move like this towards center. Clear? When you're decreasing your velocity. Clear?
Okay, sir.
Then friction always opposes the tendency. It will be away from this. Clear? This F sin theta I have written now. This I have written like
Yes,
this.
sir.
If you ask me, sir, draw again, then I will draw also. Wait. If you ask me, I will draw again. Wait. Minimum velocity. I'm solving for minimum velocity. In case of
Okay.
minimum velocity, this is the case. The car is like this. Normal. This is normal. One component is like this. And sin theta. Mg. When it is going like this, minimum velocity, it will go like this. Friction will support this. Centrifugal force. Centrifugal force will be like this. This is theta. This is also theta. One component will be f cos theta like this. One
Yes,
will be
sir.
f sin theta. Is it clear?
Yes,
In
sir.
this case, I am talking regarding minimum velocity. Now, see here n sin theta. See, we are decreasing this. Here, right portion centrifugal force plus f cos theta. My car should not skid. Then centrifugal force is mv square by r. This n sin theta is fixed 5 Newton. Okay. You are decreasing your
Okay.
velocity. You are decreasing the velocity of the car. Then centripetal force becomes 4 Newton. Clear? Centripetal force. Then it become, who will support? Friction. It become 1 Newton. Again, you are decreasing your velocity of car. Let us suppose it become 2 Newton. But I need 5. Then who will support? Friction. Friction become 3 Newton. Our car should not skid. Every time car will not skid. Clear?
Okay, sir.
Again, n sin theta is 5 Newton. Again, you decrease. Let us suppose 1 Newton. Then friction become 4 Newton. Self-adjusting nature. 4 plus 1, 5. 5. Its direction is like this. Its direction is like this. Okay. Now,
Okay,
even
sir.
if you decrease less than that, the friction, let us suppose this is the maximum value of friction. Let us suppose limiting friction. Here, up to this, it can help centrifugal force. But even less than that, like 0.5 Newton, if it is going, then friction say, I can't help you much. Clear? So up to this condition, only,
Okay, sir.
velocity will be minimum and car will not skid. Car will not skid. My objective is, even I am going with minimum velocity, my car should not skid. Clear? My car should not skid even I am going with a minimum velocity. So friction always opposite the tendency of motion. Friction help us. When normal fail, friction help us. Clear? Now you please tell, if you balance the
Okay, sir.
equation, n cos theta plus f sin theta will be what? It will be mg. Clear? Now, what is the limiting
Okay,
value of friction? Will be mu s n sin theta. Limiting value is this. Now, up to this, it can help. From here, n will be mg by what? Cos theta plus mu s sin theta. Is it okay?
yes, sir. Yes,
Check
yes.
again.
Correct, sir.
Mg. Clear? N is clear. Now, n
Yes,
sin
sir.
theta. N sin theta will balance centrifugal mv square by r, that is minimum velocity, plus f cos theta. F cos theta is mu s n. So if you solve this, it will be what? If you take n common, previous equation, sin theta minus mu s. Clear?
Okay, sir.
And write m v main. So n will be what? The solved n, I think the n is mg by cos theta plus mu s sin theta. Cos theta plus mu s. Is it so?
Sir,
Yes.
yes, sir.
Clear?
Yes, sir.
Okay, then I think it's clear to you. So mm cancel. So minimum velocity will be under root rg. So what is the range of velocity? So that your car will not skid. It will be what? What should be the safest velocity at which you should move? Greater than this, less than this. Your car will not skid any. Car will not
Okay, sir.
skid. You get a range. This question asked in the JEE also. Concept is here under root plus, numerator plus minus. Okay, here numerator negative, downward positive. So I think this is clear to you, this concept. Okay, on a circular track, center, this is R. When it is little bit raised, like this. Here now, vehicle is this. Vehicle is this. Okay, centrifugal
Okay.
force. It is like this. When car is here, how will I show you? When car is here, okay, then centrifugal force like this. This is friction. Or a circular when there is no banking.
Okay.
Clear? Now you
Yes.
little bit raise. Little bit raise. Then what will happen because of this? Like this. Normal component like this. It will support you. And cos theta. Centrifugal force. Friction will be parallel. Here. So if you look at I will stop here. Is it clear to you? It
Yes,
is
sir.
moving like this, like this. See, this is road. This is road.
Okay, sir.
Sideward, I just say it's like this. Side B. Then
Okay.
vehicle will
Yes,
move like
sir. I can.
this turn. This is a turn for the vehicle. There, normal is
Yes,
this.
sir.
One component n cos theta, one is n sin theta. Now in this circular turn, one force will be centrifugal force. Mg down. Clear? Is it clear?
Okay, sir. Yes, sir.
I think you can want to see like banking. You can watch F1 race. In F1 race, banking is there. So lecture is bit long.
Sir,
Okay, clear?
no
Yes,
problem.
yes,
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 sir.
yes. Tell me that. Is it
Sir,
clear
I
to
will
you?
watch the yes, sir. I will watch your phone races and all, sir.
F1 race you didn't see?
I will watch, sir. I usually watch that, sir.
Okay, there
In
is also
YouTube.
banking. If you see sidely, little will bank on there. I will let me check also banking. F1 race banking. Okay, I will show you. I will show you. Dinesh, is my screen visible to you? Okay, I'm sure. Dinesh, look at here. Okay, is my screen visible to you?
Yes, sir.
If you look at carefully, this is a racing car, banked. Do you see little bit raised?
Yes, sir. To an angle
Clear?
it is raised. Yes, sir.
You
Clear.
have more clarity right now. If I ask like, uh, is it clear to you, or I should explain more?
Yes. Sir, clear, sir. I can understand.
This is banking on a circular track. This is banking. Okay, side F1 race. Like, have you seen this banking? Little bit race. Here not little. Like this is banking. Like this. This is banking. Did you see sideway? Little bit elevation in the
Yes, sir.
sideward. Sidely little bit elevated.
Yes, sir. I can see.
Clear? But at the
Yes, sir.
center there is
Yes.
no banking. Clear? Center we are not doing banking. Center no
Okay.
problem, na? He will skid. Then he will definitely normal will help him. Okay?
Yes, sir. Okay, sir.
Like this is banking. See, so shall I stop?
Yes, sir.
Okay, thank you so much. Finish. This topic is finished.
Thank you, sir.
This chapter is also finished, circular motion, and I think I will discuss